In this section, we're going to introduce a new kind of coordinate. This is called a polar coordinate. So you see the word polar, and hopefully you think of, well, maybe polar bears. Well, if you think about polar bears, you have to think about where polar bears live. They live in North Pole, so the poles. So what does poles mean? They're like the north and south pole of the Earth. So if you look at this coordinate system here, you can kind of imagine this is if you were looking at the Earth from the outside, like in a space, and then you're looking straight at the pole. And these are kind of like your longitude and latitude of the Earth. And so you can think of it as this is the North Pole, and then on the other side, there's the South Pole. So you're kind of thinking of the polar coordinates like that, kind of like the Earth or the globe. So in polar coordinate system, we have instead of the xy coordinate is called the rectangular coordinate because if you kind of think about um, uh, if you kind of think about our coordinate system when you're drawing the xy coordinates, it's basically rectangular. And you go in the x direction, so that marks the horizontal, and then you go in the y direction, which marks the vertical. So that's kind of like a rectangle. So that's called a rectangular coordinate, or Cartesian coordinate, because that's the person who created the coordinate system. Polar coordinate does not have r xy. It has r theta. So r means the radius, and then theta means the angle. So for example, if we look at these coordinates, let's try to plot them on our polar coordinates. Okay, so let's say P has a coordinate of 2 pi over 3. So remember, this is in terms of r theta. So r is 2, theta is pi over 3. Now, how do we actually plot this? Well, when you look at this coordinate system, you're going to think of this middle. This is your same thing. This is your origin. And then your radius stems out from the center. So for example, the first ring will be r equals 1. The second ring would be r equals 2. The third ring would be r equals 3, and so on. And then 0 degrees is still on the positive, I guess, x-axis, or just the 0 degrees line. And then when you go in this direction, you can see the angles start to get larger. And then if you go in this direction, you're going the negative angle direction. So this would be negative, even though it looks like the numbers are getting larger, but it's just going around in a circle. So anyways, let's look at how to graph this first one. So it says r equals 2, theta equals pi over 3. So what you're going to do is you're going to start from here and then go 2 out. So then this means r equals 2. And then you're going to turn in the positive pi over 3 direction. So you're going to turn pi over 3, which is right here, right? Because it lines up with pi over 3. So this is the point. So this is point P. Okay, so again, you go 2 out, that means r is 2, and then you turn pi over 3, and then that is where the point is. Alternatively, some people find this other way faster. They find the angle first, so they know that the angle is on this line, and then they go 2 out. So, that's also another way to find the point quickly. All right, let's go ahead and try another one. I'm going to change to a different color. So this one is -1, 3 pi over 4. All right, -1 is a little bit trickier because we're going to have to go in the negative r direction. So if we're starting at the origin here, which is at the pole, when we go -1, we're going to go in the left 1 this way. So there is a reason I went this way for r, that's the positive r, and if I go this way, that would be negative r. So I would go this way, and then I have to turn 3 pi over 4 in the positive direction. Now remember, what way is the positive direction? That is counterclockwise. This is positive theta direction, positive angle direction. So then what we have to do is once we get to -1, we have to go 3 pi over 4 in the positive direction. So we're going to end up at 7 pi over 4. Again, if this is very confusing, alternatively, you could have started with the angle first. Find 3 pi over 4, which is this line, and then you want to go negative r, -1 direction. So when we're at 3 pi over 4, this line here is positive r. Why is that? Because 3 pi over 4 would line up with the positive r direction, right? Because if we start counting from here, this is all positive r. So by the time we get to 3 pi over 4, this is still positive r. So if we want to go -1, we would go in the opposite direction, -1. All right, please pause the video and then try the next one. 3, -45 degrees. All right, let's see if you got the right answer. 3 means go in the positive r, 3, 1, 2, 3. And then -45 means you go in a negative angle direction, 45 degrees. 45 degrees is right here, so this is r. All right, now okay, so let's look at this kind of question. If point P has polar coordinates 3 pi over 3, find all polar coordinates of P. Well, let's find a point first, and then we'll try to understand what all polar coordinate for P means. So go ahead and graph 3 pi over 3. All right, so the point is here, P. All right, what does it mean by finding all polar coordinates of P? So right now we're getting to this point by going r theta. Now we don't have to go r theta, right? We can also go r and then turn all the way around this way, or we can go this way and get here, or some other way. So basically there are many different ways to get to this point. So what are all the ways that we can get to this point? One way is to go 3 pi over 3, right? Now we don't have to end at pi over 3. We can say, you know what, let's just keep turning 360 degrees. So then we can say, okay, let's get to the same point by 3 pi over 3. But then if I keep turning 2 pi n, I will land on the same point. So that is true. That's one way to get to it. What's another way to get to it? I can also say 3 and then what's it? 3, we stopped at 3 pi over 3 here, and then I can say, oh, let's go backwards 2 pi n. Well, that would be exactly the same as this one. So the n kind of contains whether you turn in the positive direction or the negative direction, because n is an integer, so you have a positive and negative numbers all included in there. So that is probably pretty good with a positive r. Now, what happens if you want to go in the negative r direction? Well, let's say you start from the origin and you are going in -3 direction. Now, how do you get back to this point? Well, we know that this much, right? This much is pi over 3. So if I want to, start right here and then trying to get back to this point, one way is let's travel in the positive angle direction. So I'm going to turn this way, half a circle, and then go a little more, pi over 3, and then I would get back to the point. So then how do I write that? So that means if I go in a negative r direction, I can say, oh, go half a circle in a positive direction. Half a circle is pi, and then pi over 3 more. Right, so that's one way to get to it from the negative r direction. The other way we can talk about it is if we go in a negative r direction and then we can say, oh, let's just go here. This way is a little bit more harder to write to get to the formula that I'm going to show you. So you can say that, but then you were going to say, okay, let's go backwards pi and then forward pi over 3. So that part is a little bit annoying. So we will skip that one. Now, pi plus pi over 3 is good, but we want to cover all cases, so we can add 2 pi n. Now, this formula here, or if we look at both of them, we're going to get to the formula. So this one basically says if we go in the positive r direction, then whatever angle they give us, just remember you got to add 2 pi n to it. Kind of intuitive. We've already been learning adding 2 pi n to things too. Make sure we cover all the angles. This next one is a little bit harder to find. So it's saying if we go in the negative r direction, then let's say we get to this angle. To cover all the bases of all the other angles, we have this other part that we're trying to add. So then let's kind of write a formula for this. So if you kind of just take that part out, so it's pi plus 2 pi n, and you can say that if we're trying to simplify this formula a little bit, what we can do is basically take out a pi from there. So that would be 1 plus 2n. And then, so what we can do is to change the formula so it looks a little better. We can put the 2n in the front plus 1 and then pi in the back. So this is how we come up with the formula. So theta, which is pi over 3 in this case, plus 2n plus 1 pi. And so this is the formula to find all polar coordinates of a point. So r theta plus 2 pi n and negative r theta plus 2n plus 1 pi. All right, let's practice. If the point P has polar coordinates 2 pi over 6, find all polar coordinates for P. So remember, to find all polar coordinates, you have r theta plus 2 pi n, or you can go in the negative r direction, theta, which is the angle that's given, plus 2n plus 1 pi. So pause the video, give this one a try. All right, here's the answer. Go ahead and double check. Now, what we're going to do is be able to convert between a polar coordinate and rectangular coordinate. So when we talk about rectangular coordinate, we're talking about xy, right? Kind of like what I said before. So let's say you have this point in space, and we're going to call it some xy. Remember, xy just means it goes x amount here and then y amount here. So this is x, this is y. Now we can get to that same point if we go r theta. What is r theta? R is this length, radius, and then theta is the angle we turn. So we can get to the same point by xy or r theta. Now, how do you convert between the two? You're gonna have to remember back in vectors. So if we kind of think of this as a vector, how do we break this vector down into its x component and y component? Remember I said you have to remember this. It's gonna be the magnitude. Magnitude means the length, right? Magnitude. And then the x part is cosine theta. And then the y component is magnitude sine theta. So this is the conversion between Cartesian coordinate or rectangular coordinate to polar coordinate. All right, so let's write this down. X is r cosine theta. Y is r sine theta. How do you find r? X squared plus y squared equals r squared. How do you find theta? Well, theta, if you look at it, if you have x and y, this x and y makes the tangent ratio. So tangent of theta is opposite over adjacent. All right, let's practice. Convert the following polar coordinates into rectangular coordinates. So if you have 3, 5 pi over 6, how do you get to that same point from x and y? Well, remember that to get to xy, it is r cosine theta and r sine theta. So let's plug that in. 3 cosine 5 pi over 6, 3 sine 5 pi over 6. All right, this 5 pi over 6 is in the unit circle, so let's try doing that. 5 pi over 6 is negative square root 3 over 2, and then sine 5 pi over 6 is 1/2. So then this coordinate, let me write it here. This coordinate here is negative 3 root 3 over 2 and 3/2. So if you do that, you will get to the same point. Okay, let's go ahead and have you pause the video and give Q a try. This one, you're going to use the calculator to figure out the actual coordinate. Okay, the answer is negative 1.88, 0.68. All right, now we're going to go backwards. You have your given rectangular coordinates, you had to find polar coordinates. So how do you convert back? Well, I think it's much easier if you draw a picture. So P is at negative 1. That's right here. So we are trying to turn this coordinate into a r theta coordinate. Well, we know r is the length, theta is this one. So this is basically a vector question, right? From before, we had to find the direction, angle, and the magnitude. So it's the same idea. So then to find r, we're going to use the Pythagorean theorem. So square root of a squared plus b squared. So this is the square root of 2. And then theta is, if you imagine this as a triangle with this angle being right angle here. So remember, we were drawing right angle like that. And so we're going to label this as the actual length without the negative sign. So 1 and 1, it's pretty simple to remember that this is 45 degrees because this is an isosceles triangle, 45, 45, 90 degrees. That's why these two sides are equal. And so if that's 45, then this angle must be 45 plus 180. So this is 225 degrees. So if we're going to write the polar coordinate, it wants two polar coordinates. So then if we write in the positive r theta direction, we would say this is square root 2, 225 degrees. What happens if we write in the negative r direction? Negative r, then if you're here, how do you get to this angle? Well, if I'm here, then I can just turn 45 degrees and get to this angle. But there's a lot of different ways. You can go here 45 degrees, you can go backwards, negative 315 degrees. Negative 315 degrees. So there are many different ways. That's why sometimes if they don't say find two polar coordinates and then instead they say something like find all polar coordinates, you're gonna have to use the formula from the previous page. Okay, let's have you give this one a try. Negative 3, 0. Write two polar coordinate that represents this. All right, so the answer is 3, 180. or maybe -3, 0 degrees, or maybe -3, 180 degrees. These are some sample answers. All right, next one. How do we convert now not just a point, but a whole equation? So if we have the equation for cosine theta, so this is obviously in polar coordinate, how do you turn this into rectangular coordinate? This one is a little bit tricky. What you want to do is remember that x is equal to r cosine theta, and then y is equal to r sine theta, and then also x squared plus y squared is r squared. So if we have r equals 4 cosine, that's not really going to help us turn it into the rectangular coordinate. So what we're going to do is you've kind of looking at everything. We're trying to basically saying, I don't want r and theta. I want everything to have x and y. So in order to turn it into any of these, I need r cosine. So that means I need another r here. So what I'm going to do is multiply both sides. Whoops. I'm going to multiply both sides by r. So this becomes r squared equals 4r cosine theta. Okay, so now we can kind of do a substitution. You see r squared is x squared plus y squared. R cosine is x. So I've successfully turned everything into x and y. Now, the next question usually they ask is, what kind of shape is this? This requires that you remember the conic section from last year. So if you kind of recall, this is actually something, if I subtract 4x on both sides plus y squared equals 0, this is something I need to complete the square. So I'm going to group the x together, and then I'm going to complete the square on here. So minus 4x plus blank plus y squared equals, remember, if you add a magic number on the left, you got to add a magic number on the right. So what number goes into the magic number? 4 and 4. So now you're going to factor. And what shape is this? This is in the standard form of x minus h squared plus y minus k squared equals r squared. So this is a circle. Let's talk about specifically about this circle. This circle has hk of 2, 0. So that's the center at 2, 0. And then r is equal to 2. All right, let's try another one. Convert 4 secant into rectangular form and identify the graph. Okay, so 4 r equals 4 secant theta. Now remember, we don't have secant in our conversion chart kind of thing, so we're going to have to turn secant into 1 over cosine. So this is really 4 over cosine. And hopefully you see that there is a cosine in the denominator. I might as well multiply both sides by cosine. So r cosine is equal to 4. Now what is r cosine? That is x. So x equals 4. What kind of shape is x equals to 4? That is a line. Okay, that's just a vertical line. All right. Now let's convert into polar form. All right, so there are a few ways to do this. You can either turn x and y both into r cosine and r sine, and then kind of do it from there. Or you could basically multiply the whole thing out and then convert, which is what I'm going to do. You can do it either way, you'll get to the same answer. So what I'm going to do is FOIL and then simplify this. X minus 3 squared is x squared minus 6x plus 9. And then y minus 2 squared is y squared minus 4y plus 4 equals 13. All right, so remember the goal is to turn it into polar form. So x squared plus y squared is what? That is r squared. And then we're going to turn each other part also into polar form. So this x here becomes r cosine plus 9 and then minus 4. Y is r sine plus 4 equals 13. Now if I collect the 9 and 4 together, they equal to 13. So let's say that I put it at the end like so. You can see that if I subtract 13 on both sides, they cancel. So r squared minus 6r cosine minus 4r sine equals 0. Let's go a few steps further and actually get the equation of basically r equals something. So what I'm going to do now is factor out r. So remember, this is called the factor form because we have something times something equals to 0. So then each part is equal to 0. So r is 0, or r minus 6 cosine theta minus 4 sine theta is 0. R equals 0 is what? Well, it's just saying there is no radius. So if anything, it would just be a dot in the center of the polar coordinate. So that's kind of meaningless. So we kind of ignore that result. This one, r minus something minus something, what we're going to do is add that to both sides. Now, if you graph this in the graphing calculator in the parametric form, you can see that it is the same as this circle. All right, that's a lot of information, but let's try to practice. So change this into the polar form. Remember, you're going to turn x into r cosine and y into r sine. And then you're solving for r in terms of theta. All right, the answer is this one. And if you, again, graph in the graphing calculator, you'll see that this is a line.